So now we're just going to cover our third intuitive example. So we're going to do one more intuitive example before we move on to a little bit more vocabulary and a little bit more about the actual significance test. Okay, so in our first two intuitive examples, we found the first one, we had a sample mean that was really, really far below the 2.983 population mean. In our second example, we found a sample mean that was pretty far away, but not as significantly far away. And now we're going to look at one more that maybe isn't quite as far away as our second example was. So let's look at one more example with this intuitive idea. Okay, so for our last example, this time we're going to take a sample of 100 BC students. So we're going to take a sample of 100 BC students, meaning that we have our n equal to 100. Okay, and this time that sample average is 2.982. Okay, and of course our mu is still going to be hypothesized as 2.983, and our adjusted standard deviation is still going to be 0.25. All right, so even looking at this, not doing any computations, but just thinking about it, what I'm thinking is, you know what? I pulled this sample and the average was 2.982. That's really close to the population mean, so I'd actually think I could probably fail to reject my population mean or my null hypothesis being equal to 2.983. But we can still go through the computations and see what this will look like mathematically as well. Right, so if we're going through these computations, I have a little bell curve here. And I know that I have my population mean is 2.93. My sample mean, 2.982, I'm thinking is going to be really close to that, so I'm going to draw it pretty close. Okay, what I'm going to do is find this little p-value. I know if the p-value is large, then it means this line is really close to the population mean, which means that the actual population mean probably is equal to the 2.983 based on what we've pulled from our sample, but we can check this mathematically as well. So again, we're going to go through the z-score, find this little probability, and then draw some conclusion based on that. Okay, so here my z-score is going to be 2.982 minus 2.983 over my adjusted standard deviation, which is 0.25. Okay, and when I do that calculation, I get a z-score of 0.004. So I'm already thinking, all right, that's really close to the population mean. I think I know what's going to happen even before I finish this out. But that means that the probability of x bar being less than 2.982 is going to equal to, this whole thing would be 0.5. Okay, and then if we get a standard deviation this tiny, it kind of works like if we get a huge one. So if I'm this small, the standard deviation is so small, I'm just going to assume this area is about 0. So in reality, it's probably like 0.00000000000, etc. 1. But it's so small, I'm just going to assume that this little area is 0. So this probability is 0, which means I'll just be subtracting 0 from here. Okay, so I'm going to have a minus 0 on here. And that's, of course, just going to give me 0.5. So what this means is, if this whole piece is 0.5, this 2.982 is like right next to the 2.983. So on this, I would likely fail to reject my null hypothesis. So I would likely accept that, you know, the population average probably really is 2.993 on this. So here, we're probably not going to reject, H0, so that null hypothesis that mean was equal to 2.983. Okay, because 2.982 is really close to that. Okay, so that's likely going to be accurate. So 2.983 is likely accurate for the population. So let's say we're like, I think that the population mean is equal to 2.983. I'm going to use that as my null hypothesis. Well, if it were actually less than that, my sample would have to be further less. So I gathered a sample. My sample data concluded about the same thing as what I was thinking or what we put as a null hypothesis for the population mean. Therefore, for this, we're probably not going to reject that null hypothesis because it is so close to the standard deviation. Sorry, not standard deviation, the sample mean. So basically, when we go through hypothesis testing, we're going to put more terminology on this, but sort of use the same ideas, but have something more procedural. So when we do an actual significance test, we're going to say, okay, I'm sure this is what I'm going to do. Right now, I'm just thinking intuitively, you know what, this is close, this is far. We're going to put some more specifics onto that, though.